Hey dear, good morning. Like 30 more seconds. I see cross multiplying. What does cross multiplying mean? Who remembers your, like, I don't know, 6th grade days? Cross multiplying. When you multiply and it makes an X, a diagonal. Remember doing that? Multiply your diagonals and you set them equal to each other. Coming back to you. I hope. All right, so my questions there asked you to solve for x, and then the hint there was to cross multiply. So I'm hoping you remember. Cross multiplying is when you cross them, right? And you multiply, it makes an x, and then you just set the two equal to each other. So if you're looking at your first one there, what two numbers am I going to multiply together in the first one? X and 11. Okay, what is x times 11? 11x. Good. Then I put my equal sign, and then I have to multiply the other two. So what are the other two that I'm going to multiply together? 3 and 22. What is 3 times 22? 66. And then it just becomes an algebra problem, right, that I solve for x. I only have one step. What's my last step to do? Divide both sides by 11. And what do you get for your x value? 6. Very good. Okay, second one's exactly the same. Don't let it freak you out just because this time you got an x plus 2. What's the first thing I'm going to multiply together? X plus 2 times 2. So that means I have to take this whole thing and multiply it times 2. So when I write that, I take the 2 and I put it first. And then in parentheses, I'm going to put x plus 2. Right? Because I have to take that whole thing and multiply it by 2. What do I set that equal to? Yep. 4, which is 32. Good. So now this just becomes an algebra problem. What's the first thing that Miss Mass has to do? Good. I have to distribute that 2 to everything inside of the parentheses, right? So I'm not just multiplying the x by the 2, I'm multiplying the whole thing by 2. So if I distribute, what's 2 times x? 2x. What's 2 times 2? 4. Good. So I have to be sure that I distribute, because if I don't, then I didn't do it right, right? I have to give it away to the entire equation. All right, and now it's algebra. What's my next step? Yep, subtract the 4. I get 2x equals 28, and then my last step? Divide by 2. Good. I get x equals 14. Very nice. So today we're going to be talking about something new today, something called partitioning, but part of partitioning that you have to do is cross multiply with some fractions. So that's why I wanted to give us like a little bit of practice with that first before I kind of jumped us into a brand new. Okay, so today and tomorrow we're going to be talking about something called partitioning. Yes, my dear. Go for it. Go get it. Today and tomorrow we're going to be talking about something called partitioning. So we're going to take a little bit of notes today. We're probably not going to finish these ones today. That's okay. But we're going to get started on them. We'll do some practice with them, and we'll see how far we got. Okay. So you should have the one from the back. Go ahead and put your name on it and today's date. Today is the 5th. Cookie. Has anybody ever heard the word partitioning before? No? That's okay if you haven't. Just curious. Okay, so we're going to talk a little bit about the definition of partitioning, what it means, and then we're going to do some examples with partitioning itself. So partition just means to separate or divide a line segment. And to partition something just means to break it up into smaller sections. Okay, that's all a partition means. So if I take something, right, we've talked about a segment, starts at a point, ends at a point. Instead of saying like the whole segment is 10 inches, I can partition it to be 5 inches and 5 inches. I can just take those numbers and break them up into something smaller. Partitions occur on a line segment that are referred to as directed segment. A directed segment has a distance and a length or direction to it. And whenever we talk about partitioning, we always have a starting point and an ending point, right? Our starting point is always going to be the first one that's given to us. Our ending point is going to be the last one that's given to us. So when we're talking about a segment, usually it doesn't matter, but when we talk about partitioning, the first point would be my starting point. The second point would be my ending point. So if I call a segment AB, that means you start at A and you end at B. If I were to call it segment BA, that means I would start at B and end at A. So directed segment means you've got a starting point and you've got an ending point. Okay. Partitioning just implies that you start at your first point. And I can, like I said, I can take a segment, I can break it up into smaller pieces. And when those smaller pieces, we take them, they are called ratios. So if I say I'm going to partition a segment in 2/3 ratio, that just means the first part is 2 parts, the second part is 3 parts. How many parts would I have in total? I have 5 parts in total, right? 2 parts to start, 3 parts section. So that's all that partition. So 2 to 3rd ratio means the first part is 2, the second part is 3, and then all together I've got 5 parts. Okay? So a ratio of 2 to 3 just means pieces, the smaller pieces of each part. So if you look at those little segments there below, it says point P partition segment AB in a ratio of 2 to 3. So that means point P breaks up the whole segment into a 2 sections and a 3 sections. Which one is the P closer to? Is it closer to the A or is it closer to the B? It's closer to the A because it's a smaller number there, right? If I partition it in a ratio of 3 to 2, now which one is it closer to? It's closer to the B, right? Because it's a larger number here, so it's further away from the A. Okay, so with each of our partitions, we're going to draw a picture that looks similar to this one. And we're going to always start with our initial point on the left. Our starting point's always on the left. Our ending point's going to be on the right. So over here, why don't you label that as your starting point? Right, where we begin, and the one on the left is always going to be our ending point. Okay, so when we draw pictures of each partition of each segment, I start somewhere and I end somewhere, and we're just reading it like a book, right, from left to right. Okay, so here's going to be the steps that I'm going to do for each one of these. The first thing I'm always going to do is I'm going to draw a picture every single time. I'm going to place my starting point on the left, and then I'm going to label my points and my ratio. So every picture I draw is going to look something like this one. Second thing I'm going to do is I'm going to make two proportions. What is a proportion? What does that look like? You know what a proportion is. You just did one for the warm-up. It's a fraction. Yeah. So you're going to make two fractions, one for my x values, one for my y values. And then my last step is I'm going to cross multiply and solve for x or y. So let's do an example. I'll show you what I mean. Number 1 says, find the coordinates of point P that lies along the directed segment from A to B that partitions the segment in a ratio of 3 to 2. So I'm going to start by drawing a picture. What's going to be my starting point of my picture? I start at point A. I'm going to go through, and what's going to be my ending point? B. Now, it says point P lies along the segment and partitions it into a ratio of 3 to 2. So is my P going to be closer to the A, or is my P going to be closer to the B? Why? Because the ratio of the two, right, that's the smaller number. So when I put my P point, right, I'm going to make it closer to the B. And then I'm going to write my ratio. My ratio was 3 to 2. So that means this piece here is worth 3. This piece here is worth 2. In total, how many pieces do I have in total? 5 pieces in total. Very good. Okay, I'm going to label each one of my points. What are the coordinates of point A? 3, 4. So right underneath A, I'm going to write 3, 4. What are my coordinates of B? 6, 10. So right under B, I'm going to put 6, 10. And then what are my coordinates of P? No, right? It says find the coordinates. So instead of just P, I'm going to write X, comma, Y, because those are the two that I'm going to look to figure out. All right. Now, to make our proportions, we're going to do two proportions. One for just the X values, one for just the Y values. I can't put those two together because they're two different coordinates, right? So when I write my proportion, here is my quote-unquote formula that I'm going to do, and I'm going to write it right down over here on the bottom left. Here's going to be your formula every single time you do a proportion problem. Looks like this. Just write it first, and then I'll talk about what it means. Okay, I'm going to take my middle X minus my first X over my last X minus my middle X. And I'm going to set that equal to my ratio. So middle minus first over last minus middle. So just write it first and then I'll explain it. Middle minus first over last minus middle. Okay, so here is what that means. When I look at my picture, I won't move it yet. When I go to look at my picture, I have my first point, my middle point, and my last point. I'm just going to take the x values and I'm going to be subtracting them or finding the difference between them. So if I go back to my picture here, all of my x values are the first ones. If I follow the formula says take your middle x, so the x that's in the middle point. Which x is in the middle point? Is it 3, x, or 6? Which one's in the middle? X. So I do middle minus the first. Which one's my first x? 3. X minus 3, middle minus first, over last minus middle. So what's my last x? 6. Minus, which is my middle x? X again. So this is middle minus first, last minus middle, and I set it equal to my ratio. What is my ratio that's given to me? 3 over 2. And then now this right here becomes a proportion. So this looks like our warm-up problem that we did. So I've got two fractions. I've got an equal sign between the two fractions, and I'm going to solve them by cross multiplying, right? Making the x and multiplying across. So it does not matter which one you do first. What's going to be one of the ones that I multiply? Good. X minus 3 times 2. Now, just like in our warm-up, I want to make sure that I multiply that 2 times everything over here. So I'm going to do 2 times parentheses x minus 3. That's the first thing I'm going to multiply. Then I'm going to set that equal to, what's the other thing I'm going to multiply? Good. 3 times the whole 6 minus x. And then this becomes algebra. What's going to be the first thing that I have to do? Distribute. Okay, so I'm going to distribute this 2 to everything inside the parentheses. So what's 2 times x? And what's 2 times, careful, negative 3? Negative 6. Equals 3 times 6, 18. 3 times negative x. Negative 3x. Good. All right, now this looks a little bit more like an algebra problem you know how to solve. What's the next thing you want to move? Okay, move the 2x. How would I move the 2x to the other side? I got negative 6 equals 18 minus 5x. Definitely going to need a calculator today. What's going to be the next thing that I do? Well, be careful. Not add 18. Subtract 18. I'm running out of space. Should have wrote smaller. So I get negative 24 equals negative 5x. And then what would be my last step? Divide both sides by negative 5. You're definitely going to get a decimal. You get x equals 4.8. So now I know the coordinate of my p-value right? I know the x coordinate. My x coordinate is 4.8. Now that's fantastic, but you still have one more to do. Why? Because I need the y. So now I'm going to do the exact same thing, except I'm going to do it with my y values. Yep. So partitioning takes a hot second to do, for sure. So I'm actually going to go right below since I ran out of space. And I'll do my y value down over here. Okay. I'm going to do my y values, though, exactly the same. Instead of me subtracting, right, middle x minus first x, now I'm going to do the y's. So I'm going to do middle minus first over last minus middle. It stays the same every time. So middle minus first. What's my middle y value? Y. Minus, what's my first y value? 4. Over, what's my last y value? 10. Minus, what's my middle y value? Y again. And then I set it equal to the ratio stays the same. What's my ratio? 3 over 2. And now I'm going to do the exact same thing I just did, except with the y values. So I'm going to cross multiply just like I did with my x values. So it's going to be the first two that you multiplied together. What times what? Good. I'll take this one first. 2 times y minus 4 equals what times what? 3 times 10 minus y. And just like I did before, I'm going to solve for y. What's going to be the first thing that I do? Distribute. 2 times y gives me 2y. 2 times negative 4 gives me negative 8. I'm going to distribute now on the right. 3 times 10, 30. 3 times negative y, negative 3y. Good. All right, now I want to get all my y's to the same side. So which one do you want to move first? Okay, move the 2. How are you going to move the 2y? Subtract it. Good. I get negative 8 equals 30 minus 5y. What's my next step? Good. Subtract 30 from both sides. Again, negative 38 equals negative 5y. And then my last step, divide by negative 5. And you're definitely going to get a decimal again. That's okay. Nothing wrong with the decimal. I get y equals 7.6. So now I've done all that work. I have my x value. I have my y value. So my last step is I'm just going to write it as a coordinate. So the coordinates of point P are, which one comes first always? The x. So it's 4.8, comma, 7.6. There's my final answer. Whew. Okay, so it's the same formula every single time. Middle minus first, last minus middle is equal to your ratio. So it takes a hot second to do all of the cross multiplying, but the setup itself is not hard. It just takes a hot minute to do it. Do I have any questions on that first one? Are you ready to do another one? Great, you're going to do it anyway. Okay, let's take a look at number 2. Find the coordinates of point P that lies along the directed segment from A to B and partitions the segment in the ratio of 1 to 4. First thing I'm always going to do, draw a picture. Okay, so what is my starting point? Where do I start on the left? Point A, B, or P? Which one's my starting one? Point A is my starting point. What point do I end at? B. Now, the segment is partitioned in a ratio of 1 to 4. So is my p-value going to be closer to the A, or is my p-value going to be closer to the B? It's going to be closer to the A. Good. So I'm going to put it, it doesn't have to be perfect, but I'm just going to put it closer to the A. And then right above it, I'm going to write my ratio, 1 to 4. So if my ratio is 1 to 4, how many pieces do I have in total? 5 pieces in total. Very good. All right. So right underneath each one, I'm just going to label the coordinates just like I did for the last problem. My coordinates for point A are 1, 1. My coordinates for point B are 7, 3. And then what are my coordinates for point P? Just x, y, right? Because that's what I'm solving for. Hello, good morning. Hooray, welcome. Hi, Blaze. Yeah. No worries. That one right there, yeah, that's perfect. Yeah. Okay. All right, so I'm going to do my x's. I'm going to do my y's. I'm going to do them individually. So first thing this master's going to do, I'm just going to highlight my x's. That's all I'm going to do. Okay, I keep my setup exactly the same. Middle minus first, last minus middle, and set it equal to my ratio. Okay, so what is your middle x? X. Good. Minus, what is your first x? 1. So, middle minus first over last minus middle. What's my last x? 7. Minus, what's my middle x? X. Noticing a pattern here? Right? You know, that's how you always have like the x and the x like this. I set it equal to my ratio. What's my ratio? 1 over 4. And now this looks exactly like the last problem. Yes, I do. Okay. Now this looks like exactly like my last problem where I'm going to multiply across. And I'm going to do cross multiplication. I'm going to do what times what? My very first one. What are 2 that I'm going to multiply together?
X minus 1 and 4.
Perfect. X minus 1 and 4. So I'm going to put the 4 first. Then I'm going to put parentheses x minus 1. Equals, right? Cross, multiply. What do we multiply now?
7 minus 1.
Times 1. Great. Just put the 1 on the outside, and then I put 7 minus x inside parentheses. Okay, this is now just algebra. Your fave, friends. What do I do first? Distribute. I'm going to give away the 4 to everything inside the parentheses. So what's 4 times x? 4x. Be careful with your signs. What's 4 times negative 1? Negative 4. Now, what's going to happen on the right side, my dears? It's going to stay exactly the same because 1 times anything stays the same. But if you wanted to, you go, ooh, look, 1 times 7 is 7. 1 times negative x is negative x. All right. Now it's just get all my x's to one side, get all my numbers to the other side. So what do I do first? Well, it's already a -4. What are you going to do with it the other way? Wait, which one are you talking about, Luis? 4x. Oh, 4x. Well, I can, but then I'm going to be dealing with negatives. So my suggestion would be to move the other one. Yeah, only because then I don't have to deal with negative numbers. You'd still get the same answer either way, though. So I'm going to add x to both sides. What's 4x plus x? 5x. Okay, now what do I do? Add the 4. So I get 5x equals 11. And my last step? Divide by 5. What do you get for your x value? It's a decimal. 2.2. Yep, there's going to be a lot of decimals when it comes to partitioning, and there's nothing wrong with that. Okay, I did all that work for the x's. Am I done? Nope, because now I've got to do the y's. So I'm going to set up the y with you, and then I'm going to let you try the y's on your own and see if we can get the same answer. No, that's what we're going to do. So middle minus first over last minus middle. What's my middle y? Y. Minus. What's my first y? 1. Middle minus first over, what's my last y? 3. So minus first, last, minus middle. What's my middle y?
Y.
Yeah. So again, you should kind of notice that like my x's are diagonal here, my y's are diagonal here. It's kind of looking the same over and over again, and I keep it equal to my ratio. My ratio was 1 to 4, so I keep my ratio as 1 to 4. Now this is the exact same thing. I'm going to cross multiply, and then I'm going to solve for x. So I'll set up the cross multiply with you, and then I'll let you finish it up. So the first one I'm going to multiply, it does not matter which one you decide to do first. I'm going to do 4 times y minus 1 equals 1 times 3 minus y. And so again, if you look at what we just did with the x's versus what we're doing with the y's, do you notice how these numbers on the outside too stayed the same? Right? So it's a lot of the same thing over and over again. All right, so I'm going to give you a moment. I want you to try to finish that one. Let's see if we get the same answer. So you're distributing first. Math right, you got the wrong final answer. It means you just plug it in. I'm just looking. Impressive much. All right. I'm hoping you got 1.4. Yeah, good. Okay, so when you go to write your final answer, though, make sure you write it as a coordinate. So you're writing your final answer as P, and then which one always comes first? X. So I'm going to do 2.2, comma, 1.4. Here's my final answer. All right, so we always draw a picture first, every time. I always label my points, I label my ratios, and then I create a proportion for my x's and for my y's, and then I cross multiply and solve. Okay, so it's the same setup every single time we do one of these types of problems. Okay, we've got 4 more minutes. And the endpoint word. Can you flip it back over for a second? Yes, I will. Okay, you are going to do one problem. It's going to be your homework. Dun, dun, dun. So flip it over to the back side, and you are going to do number 4. Number 4. Skip number 3 for now. You're going to do number 4. Okay. Number 4 looks exactly the same as what we just did. So you're going to start by drawing a picture. You're going to label your x's and your y's, and then you're going to cross multiply and solve. So we only have 2 minutes. You can chill out for the last 2. Hooray! Good job today, friends. Oh, yeah. Blaze, you can go early. You can go now. Thanks for reminding me.